15,917 gross tonnage, 156 meters long, including a 25-meter-long indoor swimming pool. This is Dilbar, the largest yacht in the world by volume. Dilbar's build is a piece of art. In its primary structure, it has a steel displacement hull for strength, fatigue life, and damage tolerance. That's followed by an aluminum superstructure, which is there to save tons aloft and keep the vertical center of gravity low. You'd assume that's quite needed on a 7-deck, 156-meter platform, right? That combination of steel and aluminum, which isn't new in the yacht engineering world, uses class-approved bimetallic transition joints combined with carefully prepared cathodic protection and paint systems in order to dodge the galvanic headache. The block-built hull sections come in the form of converted hulls. The yacht can boast of web frames and longitudinal telegraphs, which are literally the pedigree of this vessel. The alloy modules are lifted on and stitched to the steel with full NDT or non-destructive testing regimes before it goes to fairing and painting. But as you probably guessed, a yacht of these dimensions couldn't be built in a traditional manner, so Lursen had to outdo themselves yet again, using a modular block construction approach. Just like in naval shipbuilding, the hull of Dilbar was subdivided into massive prefabricated blocks, each of them weighing hundreds of tons that were built undercover. Of course, these blocks have to be worked on before being installed, and they come with piping, cabling, and structural support. The blocks are then joined in dry dock with full penetration welds, and the radiography and ultrasonic methods for NDT are used. Also known as superstructure models, the interesting fact is that they have been fabricated separately in aluminum. After that, they were lifted onto the steel hull with heavy lift cranes. Alignment here is very important, because if you were to miss a millimeter, you could propagate into misalignment across decks. Thanks to this modular approach, a lot of other departments were able to begin outfitting before the entire hull was assembled. And for a vessel that was built in a 52-month deadline, you'd understand that there is a great need for stability and seakeeping as well as full control. The large freeboard of the vessel and broad beam not only give her strong stability but also high windage. In order for Dilbar to counteract roll, it focuses on stabilization, primarily through the zero-speed fin stabilizers, which are active at rest and underway. They provide damping in heavy seas and at anchor. Each of them is controlled from a computer and is hydraulically actuated. The vibration and noise control are also very important here. Machinery spaces were built on the raft foundations, while steel frames were mounted on flexible elastomere pads. This process was focused on preventing the engine vibrations from transmitting to the guest decks. The cabin floors were mounted as floating ones with air gaps and sound insulation. When it comes to the bulkheads, the double wall construction to further isolate noise has been implemented. Thanks to these engineering masterpieces mounted inside Dilbar, the power that the engines transmit, 30 megawatts, and the noise are similar to what you hear in luxury hotels, close to zero. The hydrodynamic optimization and propulsion matching were key to this project. The preliminary hull form development started with a parent hull form based on Espen Oino's styling constraints, then modified the underwater sections to optimize fluid number range resistance. At the length of 156 meters, wave-making resistance is a very big challenge, so slenderness ratio and prismatic coefficient are tuned to meet the operating window of 18 to 22.5 knots. The CFD optimization is also a piece of art itself. Due to the viscous flow CFD to iterate bulbous bow geometry, the for body flare and transom flow, the optimization process becomes a lot easier. CFD is also focused on the flow into the propeller plane to minimize skew and cavitation risk while maximizing the propulsive efficiency. And when we talk about the yacht with the largest volume, we need to talk about the HVAC and thermal systems. The objectives were quite clear, but putting them in practical use is a bit more difficult than originally imagined. The primary component is the central CWP, or chilled water plant, which contains multiple high-capacity chillers in a redundant N+1 configuration. Because of the size of Dilbar, multiple chillers sized in the multi-hundreds to low thousands of kilowatts each are included. Their goal is clear: feeding a chilled water ring to AHUS and fan coil units. Many of them are placed in separate machinery rooms equipped with acoustic enclosures to meet the quietness criteria. The AHUS, or air handling units, are very large, such as the ones used for public spaces. Their goal is not only to provide high fresh air, but also to dehumidify the air, while the smaller ones are used for cabins and the owner's apartment. Their way of operating is very easy to understand. Low SFP, or specific fan power fans, multi-stage filtration, and heat recovery exchanges, with the emphasis being put on the sound attenuation lining. What about the propulsion of this ship and the power plant? Unlike the traditional direct drive yachts, Dilbar uses a diesel-electric power system, also known as a floating power station. 6 medium-speed engines form the generating plant. 4 of them have a power of 6.083 kilowatts each, while 2 of them have a power of 3.042 kilowatts each. The total electrical capacity of Dilbar is 30.4 megawatts, and if you wondered why they've decided to go in the diesel-electric direction, it's quite easy. It allows more flexibility. The engines can be switched on and off depending on the hotel and propulsion load, which allows the operators to always run near optimal efficiency. On top of that, the vibrations are isolated due to the engines being decoupled from the shafts, so the quietness is a big factor that needs to be considered here. With 6 engines, the vessel can tolerate multiple failures without losing propulsion. Speaking of which, 2 large electric motors drive conventional propeller shafts. Each of them is powered via variable frequency drives, allowing very precise control of shaft speed, reduced noise, and lower vibration. The power station principle is the common one in vessels of this caliber, the DC/AC bus approach. It means that the ship is mounted with multiple medium-speed diesel genset generators tied to a common AC main bus that likely includes medium voltage on board. The generators feed the propulsion converters as well as the motor drives, which are VFDS, and the hotel transformers as well as the LV distribution panels used for lighting, galley, HVAC system, elevators, and hotel loads. And did we talk about the interior? This part itself is putting Dilbar in a different league, one of its own. Let's start with the cabling. Around 1,100 kilometers of cables were laid, including power, control, data, and entertainment network. The HVAC system is crucial. On a ship of this magnitude, the climate control systems alone consume megawatts. Air handlers, chillers, and ductwork are designed to manage cabins, but also massive areas like the pool area and the spa centers. A characteristic that separates Dilbar from other superyachts is the indoor pool. The dimensions are quite insane: 25 meters long, 6 meters wide, and varying depths between 1 and 2 meters. It's quite a challenge to build such an engineering masterpiece into a vessel, so engineers had to reinforce deck structures with girders and integrate baffled tanks to minimize sloshing. If this hadn't been done, dynamic loads strong enough to deform the structure would have been created, further endangering the structural integrity of the vessel. Let's not forget about the helicopter facilities as well. 2 helipads were structurally designed for heavy rotorcraft, such as the Airbus H175 that allows for a 7.5-ton max takeoff weight, thanks to the firefighting systems, refueling stations, and crash rescue equipment, as well as the reinforced desk. The yacht code and aviation safety standards have been met, so you have yet another taste of luxury. The paint itself is quite the work of art. The cream-colored finish required a long fairing and coating process, multi-layer epoxy fairing, primers, and high-gloss polyurethane. For a project of this scale, small surface imperfections are quite unacceptable. The interior of Dilbar is courtesy of Winch Design, which focused on implementing rare woods, marbles, and custom fittings. Each of these installations had to account for ship motion, requiring flexible joints, special adhesives, and hidden expansion gaps. So from the largest indoor pool ever built in a yacht to every fine detail that's been worked on with precision. These are the characteristics of Dilbar, the largest by volume yacht in the entire world.